you hear me now? Okay. Okay, I'll just get started. So I saw a bunch of droopy faces earlier this morning, so I'm hoping the coffee and the sugar is kicking in. I'm just going to get started. So my talk is about static types in JavaScript. Just a quick introduction about me.
I think we need higher volume. Can you speak up until it picks up?
I'm the co-founder and lead engineer at Sapien.ai. And what we do is we use artificial intelligence to build bots for the enterprise. And what I nerd out about, I'm a huge JavaScript and web developer nerd. I love functional programming. I'm also, because of my company, I nerd out about AI, NLP, and conversational UI and UXs. Okay, so the main goals for today are what are static types, how to use static types in JavaScript. Then we're going to talk about some of the benefits and trade-offs, and then close off talking about knowing when to use static types. So quick definition. So a type is simply a classification of data which tells the compiler or an interpreter how the programmer intends to use the data. So in simpler terms, it kind of defines the inputs and the outputs. You have a function, and so types help you define the input and the output. And so there's two types of types. There's static, which is people typically say it's statically typed, and that means the type checking happens at compile time. And then there's dynamic, which means the type checking happens at runtime. And I'll give you examples of both. So in Java, you typically have static types. You define your type statically. And what this means is, for example, for the variable result, you determine that it's a Boolean while you're coding. And so here we say Boolean result is true, and so that will compile correctly. But if you did Boolean result equals 1, 2, 3, that won't compile because you said it's a Boolean, but you're declaring it as a number. And so basically what types do is they help you specify program invariants, which means like basically just logical assertions and conditions under which a program will execute. And in JavaScript, types are dynamic. So we don't say result Boolean true, we just say result equals true, and then that type checking, the context allows JavaScript to establish what type of the data is being declared there. So long story short, statically typed means it's declared up front, it's explicit, and the type checking happens at compile time. Dynamically typed means there's no type declaration, it's implicit, and the type checking happens at runtime. And even though JavaScript is dynamically typed, we have these two really cool tools that have come out a few years ago that allow us to use types in JavaScript. The two ones that I know that I use most are Flow, which is put out by Facebook open source, and then TypeScript, which is put out by Microsoft open source. They're both great. I use both. I don't think I have a choice over either one, but there's slight differences. With Flow, it's much more of a checker, meaning that you put @flow on top of the files that you want to type check, and then it will check the types, but it won't compile it. It won't compile it back down to JavaScript. You have to use something like Babel to convert that stuff back to JavaScript and remove the types that you put in there. Whereas like TypeScript is both a checker and a transpiler. So it will both type check and then also pipe it out as JavaScript. And with TypeScript, you declare your file, instead of .js, you do .ts. And that's how it knows to type check that. And so I'm going to quickly go through syntax for people who might not have ever seen types in JavaScript, just so your brains kind of get used to it, because it takes a while to kind of train your brain, especially if you've never coded in a statically typed language, to kind of not feel like this is super clunky and just to get used to the syntax. So some of the basic ones, like Boolean, so Preethi is awesome. How it goes is you put a colon, you put the type, and then you put the data. Number, you just simple. Again, the colon, number equals 10. And now TypeScript also allows you to declare hexadecimals, binary, and octals. Now that ECMAScript has those as well. Strings, pretty straightforward. And then arrays. So there's two ways to declare arrays. You can do the type and then brackets, or you can say literally say array and then put the type in there. So what I mean is you can do number brackets, and that'll say it's an array of numbers, or you can do array those brackets number, and it'll be the same thing. Either way, it's up to you how you declare it. The any type. Any type means basically you're opting out of type checking. This is very useful when you might be using a third-party application and you don't know the type, or it's like dynamic content and you don't know the type. And in that case, you can opt out of type checking by just using any type. So if you're not sure, you can say this is an any type and declare it as anything you want. And then it won't, and even if you try to use properties on that object or whatever type it is, it won't throw an error because it's not type checking. Whereas if you did the same thing, if you say, I'm pretty sure this is an object, but you try to do toFixed on it, because objects don't have a toFixed property, that will type check and it'll error. Another time that any is useful is when you, for example, might have an array, but they're not all the same types. You want to opt out of that type probably, so you just do any. Void is kind of like the opposite of any. Basically, you're saying there's an absence of having any type at all. And so typically, this is useful when your function doesn't return anything. You're just saying it's void. It returns void. Null and undefined, pretty straightforward. So null and undefined are their own types, and they're a subtype of every other type. Meaning, like, you can say string 1 you can say it's string and it's null, or you can say it's null and it's null, or you can say it's undefined and it's null. So typically what I do is I use something called the no implicit null, I think it's called. Basically, it doesn't allow you to use null and undefined as subtypes of any other type, so that you only use null and undefined specifically as null and undefined. I'll clarify what I mean later. Okay, interfaces. This is super useful. Interfaces help you declare the shape of values. So you can type check an object by just doing something like this, where you have colon, what the name type is, what the age type is, and actually declare the object. Or you can use an interface and say, my interface person has a name that's a string and an age that's a number, and then use that interface wherever you declare that object. You can also have interfaces for functions. So let's say you have a function xy, you know it takes 2 numbers and it returns a number. You can just declare the shape of that function and use that interface for whichever function follows that interface or that contract. The other cool thing about interfaces is you can have optional properties. So optional properties means it could exist, but it doesn't have to exist. So your person, let's say the first name must exist, but the last name doesn't have to exist. It's optional. You can just put a question mark before the colon, and the compiler will know that it's optional. And this becomes useful particularly when you can still declare stuff that are possibly there, but you're not sure. But you can also still ensure that you prevent use of any properties that are not there. So in this example, let's say my return says hello person first num instead of first name, and so because it's not there, it will throw an error and help you catch that. Another thing about Flow and TypeScript is they infer types. And they infer types in 3 situations. Either when you're declaring the actual, when you're instantiating the variable, or when it's a parameter to a function, or when it's a return type. And what I mean by infer is, let's say you're declaring x equals 3, or you're instantiating x as 3, it will know that x is a number. And so next time you use it, it will type check it as a number. You don't have to always put the type there. And this kind of frees up you from having to put x colon number all the time. And there's also something called contextual types. So because TypeScript knows that on mouse down on window takes a mouse event as a parameter, it will type check and it'll throw an error because you tried to do buton instead of button on the mouse event, and buton doesn't exist. So that's a contextual type. it does it automatically for you. But if you said mouse event any, it won't do the type checking and it won't throw the error. Another kind of type is type alias. This is basically you create a new name for a type. And they're very similar to interfaces, but these are not just objects. These can be primitives, there can be unions, they can be tuples, any other type, basically. And I'll kind of show how this is used in the next slide. An intersection is a type that combines two different interfaces. So you have a person, you have a teacher person. You want the teacher person to have the properties of both the person and the teacher, so you can do a intersection. This is super useful for like mix-ins in JavaScript. Union is kind of almost the opposite of intersection. Union is when you say it can be this or this. And this is useful when you have a program that needs to deal with different kinds of data all at once, but you don't know what it is at the moment you're declaring it. An example is, let's say you have some lucky number, and that lucky number can be a number or it can be a function that returns your lucky number. You can say your lucky number or resolver equals either a number or a resolver, and then you can use that within your functions. Another thing to note about unions is that you can only access properties of unions that are in all of the members. So let's say you have an interface circle and an interface square, and you're saying a shape can be a circle or a square. When you try to access that shape's area, that will not throw an error because area exists in both the circle and the square. But if you try to access radius, it'll throw an error because if your shape ended up being a square, then radius doesn't exist. So it's telling you, hey, like it's possible that radius doesn't exist. So I'm going to throw an error. Another cool, somewhat advanced thing is discriminated union. And what this does is, let's say you have three shapes: a circle, a square, and a rectangle. A discriminated union means you have basically three things. One is you have a type that is common to all of them. So in this case, type is common to all three. You have a type alias that is a union of these types. And then you have a type guard. So I'll show you what a type guard is. So you know it's the shape. It can be circle, square, or rectangle. And the common property is the type property. OK. And then you have a function that takes your shape, and you're switching on the type of the shape that is. So this will work fine. But let's say you didn't switch on the last type of shape. You only did square, rectangle, but you didn't do the circle. It'll throw an error because it's saying that you didn't actually check for the third type, which a shape can be, and this can actually return undefined. And so it'll catch that for you, which is super useful in some situations. So this will not error if you add that. I think last thing is generics. So generics are super useful when you don't know the type in advance, but you know something about it. So an example is the identity function. We know that the identity function always takes the same type and returns the same type, or the same thing and returns the same thing. So if it takes a number, it returns a number. If it takes an array, it returns an array. But it can take any kind of type. So one approach is you can say identity number and declare it as something that takes a number and returns a number. Identity object, something that takes an object and returns an object. That gets repetitive, obviously. Or you can do identity, it takes any and returns any, but then you have no type safety at that point. So what generics allow you to do is use a type variable to say, this takes a certain type and returns the same certain type. And how you would use this is you'd say identity, it takes a number, and now my function is guaranteed to return a number. And later on, you can say, it takes an array of numbers, and it's guaranteed to return an array of numbers. There's a lot more to check. Those are just the basics, and like TypeScript is a pretty big API, so there's a lot more advanced stuff to check out if you're interested in types. I'm not going to go through all of them. The main thing I would love to focus on is some of the benefits that you do get from using types. One thing, as you're already probably seeing, is it's helping you detect bugs early while you're coding. And because, again, we specify our invariants when we're coding, it doesn't let us run the program unless there's no errors. And if you violate any of those invariants, it'll throw an error. So an example, let's say you have a calculate area function, takes a radius, and it calculates the area. And let's say at some point in your program, you pass in a string instead of a number to that. This will return a big fat nan. And if some other part of your code was using area, assuming it was a number, your program will throw, and there will be an exception. But if you had types, you could have never, ever done that because it would have caught that while you're coding. Other benefit is that it's living documentation. This is an example from when I was actually at Coinbase. We had something like this. It was a different function, but it was something that was trying to calculate the payout date, and it took three input variables, and then it returned the payout date of that purchase. But I had no idea what quote meant, what amount meant, what payment method meant. Like, are those numbers, are those strings, what are they? Am I passing the entire object into this? And so I had to grep the code base to figure out how to actually use this function and what I needed to pass into this function. Whereas, like, if I had types, I know that quote means like I have to pass in whether it's a quote or not. It's a Boolean, and amount is the amount of the purchase, and payment method is the type of the payment method in a string format. Like, it would have been so much more clear to me just by looking at the code what it's expecting. And the argument against this is that people say, oh, well, you can use JSDoc type comments to do the same thing, and it's absolutely true, and that's what existed before I added flow type to the code base. But this is it's not structured per se. It's text. 2, you're not guaranteed that everyone writes good comments. Some people write really good comments. Some people write really, really crappy comments. Some people try to be really funny in comments. So you have no idea if it'll be good. And then 3rd, I almost always forget to update code comments or take them out when they're not relevant. So you find like irrelevant code comments littered around your code base a lot of the times. Another reason is it reduces convoluted validation logic. And so going back to our calculate areas function, let's assume it takes an array of radii, and it iterates through that and calculates the area for each and returns you an array of areas. But of course, if you don't check for the input of the radii, it can throw an exception. So then you're like, okay, let me try to guard against all those potential bad input arguments. So radii can't be null or undefined. It can't be a non-array input. And then within the array, everything must be a number. So you have to each step of the program, you're checking, making sure that I can actually calculate the area on the number in the array. Or the 3rd option is you can just do types, and it's much more simpler. The code looks like what it was supposed to look in the beginning. Another benefit is you can refactor with greater confidence. What I mean by this is, let's say you have a function greeting, it takes a name, and it says, hello, name, how are you? Later, you refactor it because you want to pass in the whole person object, because maybe later in that function, you want to use the first and last name or something. If you make that change and you still pass in Preethi as the name, then what you get in the output is hello object, how are you? Which is not very pretty to a user, right? And especially if you don't have tests checking this kind of stuff, which sometimes you don't, this can be really unpleasant to a user. So if you had types and if you updated the code in that way, you're forced to update the types. You have no choice. And so at that point, if you tried to even pass Preethi, it would obviously throw an error. Another benefit is it reduces the number of unit tests. So going back to our really ridiculous error checking function, we could do this, and then we can write a bunch of tests to say, if you pass in undefined, then it should throw an error. If you pass in a string, it should throw an error. If you pass in an array with null in it, it should throw an error. Or, again, you can go back and just put a type, and that just eliminates those 3 tests that you had to write. So I think, in general, I think of types as, like, you write tests for logic, and then you use types for checking data types. Like, types help you eliminate all those tests where you're testing for the type of the data, which I think is kind of silly sometimes. Lastly, it helps eliminate an entire category of bugs. So let's say you have a React application or some Angular application. You know the property, you have a user prop and a messages prop. You go fetch it from an API, and then this is how your component looks. You're saying, hello, user.name, and then you're showing their messages in an unordered list. Now let's say your API is unreliable and it can return undefined or null or something, and maybe your user or your messages are undefined, you'll get an exception. So you know that ahead of time, so you're like, okay, I'm going to define my app props as maybe user and maybe messages. Those can be undefined, those might be null. And so that way you're forced, whenever you use these, to null check against those 2 properties. So even if you went to go write a component that didn't null check, TypeScript would say, hey, you said user could be undefined, but you didn't really type check against it, or like you didn't check that it's not, you didn't check that it's undefined to handle that case, so I'm going to throw an error. And so then you're forced to go back and fix it and properly handle that case. Some trade-offs. Of course, a lot of upfront investment. Like you saw the syntax. It takes time to learn. You have to sit there and learn the API. Sometimes you're just hacking and you just want to forget about types. So it's, it adds a lot of upfront investment. Like for me, I got obsessed with types when I learned Elm, which is a functional programming language. But learning the types was half the battle in learning the language. It took me twice as long to learn Elm as it took me to learn JavaScript just because of types. So you have to be willing to put in that time investment if you want to reap the benefits of it. Verbosity. So like, obviously, this is much nicer than something like this when you're first looking at a code base. I mean, once you get used to it, once your eyes get trained to see it, you'll actually appreciate the second one. But in the beginning, it just feels like, oh my God, there's so much code. How do I just like scan this and understand what's going on? It's the same thing. Like if you want to determine an interface, you like basically double the lines of code. But the argument against this is, one, as I showed before, it can help eliminate a lot of tests. So you're kind of reducing lines of code there. So the lines of code you add, I don't know, I think it equals out. And the other thing is, as I showed earlier, you reduce a lot of the validation logic you were doing for input and output types. So you reduce lines of code there. So the verbosity, I don't know, it's kind of like there's a trade-off there. Third, it takes time to master, especially because sometimes you might not want to type check some stuff. It just takes a lot of practice and experience and careful thought to figure out when it makes sense to type check, when it makes sense to use generics, what types to use in what situations, and so forth. And lastly, it can slow down rapid development. Like if you're just literally trying to hack together something, you might not want the extra burden of adding a bunch of types to your program. And if it's always getting in the way, you might start to lose focus, and we all know how much we hate to lose focus and run into errors when we're coding because it just takes twice as long. So I guess to close off, like, should we use static types in JavaScript or not? I don't think there's a silver bullet answer, just like everything else in programming. I think when it makes sense is when your program is critical to your business, when it's likely to be refactored or needs to evolve over time. That way you have contracts against the code whenever you're refactoring. When the program is complex and has many moving parts, you probably want some safety there. And lastly, when the program is maintained by a large team of developers who need to really understand and grasp the code quickly, they can just look at the types and the contract of the code and kind of understand it quickly. When it might not make sense is when the code is short-lived or it's not critical to your code base, or when you're prototyping and trying to move really quickly, when it's small or simple. And then when you're the only developer or you're only 2 developers, I think like it kind of becomes a burden at that point. So closing thoughts, I think the beauty of being a JavaScript developer today is that because of tools like Flow and TypeScript, we finally have a choice of whether to use static types or good old JavaScript.
Awesome.
That's it.